Greetings and salutations out there, world savers. It's Mr. J coming at you. Got another little math session for you. This is Gecko Math 2.2, and today we're going to talk a little bit about the distributive property. So what is the distributive property exactly? Well, you need to look at the word distribute or distributive itself. Distribute means to kind of hand out, or to give to, or to join up, if you will, or to pass through. And when you distribute or multiply a number outside of a parentheses, like the letter A, you distribute that through with the other numbers inside the parentheses. For example, I have A times B plus C. So I would start by distributing the A and distributing it in here with B. So now I have A times B plus, and then distribute the A through here, A times C. So you're passing it through each part or each point. I'll give you a little closer look here. Alright, I've got some examples of how this would work. So if I want to distribute the A times B plus C, I start by distributing the A because it's outside the parentheses. Then I'll distribute it through here and show you how it works. So first of all, I start with A times B. I'll distribute the A through there, plus A times C. Okay, well, now let's look at it if it goes through a little bit differently. B plus C times A. Well, first of all, I would distribute the A through there, but my order is going to look a little bit different. Since my A is on the back end of the parentheses, it would be BA plus CA. Okay, you see how that works? So I still I distribute the A through, but this time I'm going on a little bit backwards. So BA, or B times A, plus C times A. Alright, there's your answer. Well, let's see how it would look with the subtraction problem. I've got A times B minus C. Well, again, I just distribute the A through to the first one. That gives me AB, or A times B, minus A times C. Try it on the last one. Did you get B times A minus C times A? If you did, you are correct. Alright? This is an example, oops, sorry about that. This is an example of an equivalent variable expression. It's equivalent because, well, as you can see, these are all equal. Okay? And I've used variables. I've used variables right here. A is a variable I used, B is a variable, and C is a variable. That means I could stick any number in there that I want. And these are expressions because, well, it's a math problem that I'm trying to work out. Well, if you're still stuck, let's try it with some actual numbers and look at how it would work. So I'm looking at 3 times x plus 7. Well, first of all, I distribute the 3 through. 3 times x would give me 3x. Plus 3 times 7, that's 21. So I'm looking at 3x plus 21. Let's look at the next one. I've got negative 5 times 2y minus 3. So let's look at it like this. I've got negative 5 times 2y. That gives me negative 10y. You see where I got the negative 10 from? Negative 5 times 2. And then I just bring my variable over. Okay? Also, what I'm looking at is now I've got negative 5 times 3. Okay? So negative 5 times 3 is negative 15. What I forgot to add in was I forgot to put my equals in here to make these an equivalent numerical expression. Anyway, now I'm left with negative 10y minus negative 15. Well, I've got rules for adding and subtracting integers, and anytime that I'm subtracting an integer like this, do you remember what your rule is? We add the opposite. We add the opposite. So actually I have negative 10y plus 15, because 15 would be the opposite. And there's the answer that I'm looking for. Obviously, there's some further steps down the line, but we won't get to those in those lessons. That'll be another week or so away. Anyway, I have 3 problems that I'd like you to try. And these I need you to bring with you when you come on Monday. We'll start off with 9 times 3m plus 5. Then we will start with 7 minus t times negative 4. And then we'll start with negative 2 times 6y minus 4. Okay? Good luck, give it a shot, and we'll see how you did on Monday. Have a good weekend.